The Earth once turned upside down. Image of a change of the Earth's position. Can you imagine that? It was so dramatic that it could force the entire planet to tilt to the side after a few million years, with such an inclination that Alaska would be in Ecuador. Scientists from Princeton University have secured the first clear proof that such a large-scale movement must have happened in our world in the distant past. Analyzing the magnetic composition of very old sediments found in faraway Norway in the Svalbard archipelago, Adam Malouf of Princeton University has provided solid evidence for a theory formulated about 140 years ago that dealt with how the Earth would regain its balance in case of a large and unequal distribution of weight inside or on its surface if it ever developed it. The theory known as true polar rotation, TPW, true polar wander, assumes that if a body of significant weight, such as an oversized volcano, ever formed some distances from Ecuador, the force developed by its rotation planet would gradually push it away from the axis around which the Earth revolves. Kindly support my Patreon account since YouTube has again demonetized my YouTube channel. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below. So you can imagine the weight of a volcano inflating would perhaps cause the world to wander. True polar wander, TPW. True polar rotation. Now, if volcanoes, solid Earth, and other similar masses subject the Earth's rotation ever created a critical imbalance value, the planet would tilt and rotate until the extra weight was redistributed along the equator. The sediments were recovered from Norway, and they provide the first satisfactory evidence that a complete polar rotation occurred on Earth about 800 million years ago. This is what Malouf said. He's an assistant professor in the Department of Geological Sciences. He said, if we can find evidence in other parts of the world that confirms this proof, we will gain a thorough knowledge of our planet's tolerance for such dramatic changes. The Malouf team, which includes researchers from Harvard University, the California Massachusetts Institute of Technology, and Princeton University, published their findings in the Geological Society of America Bulletin Friday, August 25th. Complete polar rotation, or total polar rotation, total polar wander, TPW, is different from the more familiar concept of the movements of the continents, which is the slow movement of one continent relative to another along the Earth's surface. Polar rotation, though, can cause the entire planet to tilt at a rate of several yards a year, about 10 to 100 times faster than the continents move between themselves due to tectonic plates. Although the two poles will continue to point in the same direction in agreement with the solar system, the process will obviously lead to the movement of entire continents from the tropics to the Arctic and vice versa within a relatively short geological period, they said. While the notion that continents move slowly towards each other is a well-known hypothesis, the less common theory of complete polar rotation has been discussed since the mid-19th century, several decades before the theory of continental motion was proposed. But when it became clear in 1960 that the continents were moving under the influence of the sliding of tectonic plates, this fact explains so many dynamic processes taking place on the Earth's surface that the theory of complete polar rotation became a dark and distant hypothesis. Even though it does take place, planetary scientists are still talking about polar rotation, but for other planets like Mars, because a large-scale movement of rocky volcanic mass from the Tharsis region is on Mars' equator, says Malouf, but because the Earth's surface is constantly changing due to the movement of the continents and the overlapping of the crustal plates in the oceans, it's more difficult to find evidence for the hypothesis that the Earth spun hundreds of millions of years ago, as probably happened on Mars when Mars was still geologically active. Nevertheless, the sediment studied by the team at Svalbard from 1999 to 2005 may have provided the much-needed proof. It's known that when a rocky mass sinks to the bottom of the ocean, forming layers of sediment, tiny magnetic shavings contained within this mass are aligned along the lines of Earth's magnetic field, and when the rock hardens, these shavings are a reliable indicator of the direction of the Earth's magnetic field at the time the rock was formed. Thus, if such a rock rotates due to the dramatically large geological event, its magnetic field will have an abnormal orientation, as is the case with rocks examined by Malouf's team, and that's, of course, where he found the complete polar wandering. Malouf said, "We found just such anomalies in the Svalbard sediments. We have made every effort to find another explanation for these anomalies, such as some very lightning rotation of the crustal plates on which the islands are located, but none of the alternative explanations is valid as a fact of a complete polar rotation if we also take into account the other geochemical and geological data concerning these rocks," he said. The findings, he says, could possibly explain unusual changes in the ocean's chemical environment that occurred about 800 million years ago. Similar changes have occurred in ancient times, says Malouf, but scientists believe the Ice Age is to blame. Scientists have found no evidence of a possible glacial period 800 million years ago, and the change in the ocean at this critical juncture remains one of the greatest mysteries of our planet's history, he said. But if all the continents suddenly overturned, and the rivers began to drain water and nutrients in the tropics instead of the Arctic, for example, mysterious geochemical changes could occur which science cannot explain. Because the team drew all this data from the Svalbard Islands, Malouf says their next priority will be to look for evidence to support their findings, researching sediments of the same date but in other parts of the world. This is difficult, says Malouf, because most of the 800-million-year-old rocks have long since disappeared. Because the plates of the Earth's crust slide on top of each other over the years, they carry with them much of the history of our planet in the bowels of our Earth. However, an area identified by Malouf's team in Australia seems to have a lot of potential. Malouf says we cannot be sure of the findings until we find a similar composition and magnetic orientation on rocks of other continents. Rocks of the same age have been preserved within Australia, so we will be visiting the area over the next 2 years to look for additional evidence. If we find it, we will be much more sure of the correctness of the theory. He goes on to explain that a complete polar rotation, a total polar rotation that is, was more likely to have occurred when the Earth's land areas were close together, forming a supercontinent, something that has happened at least twice in the distant past. But we should not worry that such a big spin is going to happen again soon, because the mass of the Earth has a fairly balanced distribution today, he says. This is on a Greek article I've translated for you. Please leave your comments and thank you for your support.